So now we're going to start dealing with compound events. Now compound events consist of two or more events. And we sort of already talked about this with when you're calculating stuff like how many outfits you can make when you got 5 shirts and 5 pairs of pants with the counting principle, but this is a little bit more in detail. So a compound event is, there's two different types. There's independent and dependent. With an independent events, the occurrence of one event does not affect the probability of another. For example, flipping a coin and rolling a dice. It's not like one will affect the other. So the way you figure out the probability of an independent event is by multiplying the probability of each event. So the probability of A and then B is just the probability of A and then the probability of B. So what's the probability of rolling a 5 on a 6-sided number cube and heads on a coin flip? Okay, so let's figure this out here. So what's the probability of rolling a 5 on a 6-sided number cube? 1 favorable out of 6 possibilities. What's the possibility of getting heads on a coin flip? 1 favorable out of 2 possibilities. So you just multiply them together. We end up with, if you were to predict that you'd get that or wanted to get that, you'd end up with 1/12. Now down here, dependent events are when the occurrence of the first event affects the probability of the second event. It's a little bit more complex since you have to take into account that. For example, the probability of correctly picking a card out of a deck, and then picking a second card out of the same deck without replacing the first. Dependent events generally happen when you choose something and then do not put it back in the pile so it can't be chosen again. So if the event of B depends on event A, then the probability of A and then B is equal to the probability of A times the probability of B after A. So what's the probability of picking the Jack of Hearts out of a deck of cards and then picking the Ace of Spades? If you're not putting them back, then probability of picking the Jack of Hearts is 1 out of 52. And what's the probability then of picking out the Ace of Spades? Well, you no longer have 52 cards. You took this one out. So it's now going to be 1 out of 51. And we just multiply 52 times 51, and we'd end up with what the actual probability would be, which in this case is 1 over 2,652. So now we're going to move on to the next one, which is Josh wanted me to go ahead and focus on him for the problem, so let's go ahead and come up with this. Apparently, Josh likes guavas. So Josh Weiner has a bag of 5 different flavors of Jelly Bellies in it. Guava, apple, lemon, and cherry, and pineapple. So those are all the different flavors. There are 10 of each flavor. He loves guava and wants to save it until the end. So if he pulls out a guava, then he puts it back. What is the probability that he will pick out one guava? Well, how many jelly beans are there total? Well, there's 50 possibilities. And there's 10 guava. Or if you took that into account and you saw that there was 5 different flavors and they were equal amount, you could simplify it to that. So 1 out of 5 for the first one. What's the probability that he will pick 2 guava in a row? Well, if he picks one guava, then he keeps it in there. So the probability of picking out 1 guava is going to be this. I got it right over here. 10 over 50. And then he's going to put that one back if he ends up with that guava, so he's going to do it again. 10 over 50. So this would be independent because they aren't affecting one another. If he picks something else out, then it would affect it. So, so this would be 100 over 2,500. And then, now, that is how you'd figure this out, and then we just simplify it. It would be a 1 out of 25 chance that he would get 2 guava in a row. Now, if Josh changes his mind and he decides that he wants to eat them no matter what order they come out of, what are the chances he'll get a guava and a cherry? Well, the first time he has a 10 out of 50 chance getting a guava. That we've already established. But if he gets that guava, then suddenly he's going to now have a 10 out of 49 chance, because there's 10 cherry left and there's 49 jelly beans left. So we multiply that together, we're going to end up with 100 over 2,500. 450. That should be right. And when we did that, obviously it ends up being a little bit different. And this would be the same even if you went ahead and had, well, he's going to pull out a guava and then a guava the second time. It would change a little bit, actually. So let's do that problem. If he were to go ahead and come up with 2 guavas in a row, and this would simplify to 10 over 24, 245. We'd simplify that to 5, so go ahead and do this. This will be 49, I think. I think that's right. And so if we did that, if instead he decides to do it this way and he wants 2 guava in a row this time, well, the first time he's got 10 out of 50. And the second time, he now has 49 jelly beans to choose from, but he now has 9 of the guava. So suddenly that changes the equation a little bit. And so it's going to be 90 over, still is the same amount on the bottom, so 2450. So you can tell how this ends up going ahead and changing things a little bit. And that there is simplified as best as we can. So 9 over 245. So that's how you go and figure out this. And it's very important to figure out, whenever you see a problem like that, is it an independent or dependent event? And just remember, Josh and guavas.